So today we're going to do 3 examples using the Fundamental Theorem of Calculus Part 1. Through your video and through our other examples, we have learned that the derivative and the integral are just opposite or inverse operations. Since that is the case, when we need to find the derivative of our function g, it really just undoes that integral function and then accounts for the function of g of x rather than g of t in this function. So we're going to replace our t with our x and undo that integral. So the derivative of our function g becomes the cube root of 7 plus 2x squared. Nice and easy. Now you can see in example 2, they've replaced, instead of running the integral from 0 to x, we're now running the integral from x to 0. So that's just one of our properties of integrals where we can take the inverse and then negate the interval. So what we're going to do is we're going to start by rewriting this function. Instead of the interval x to 0, we're going to write this as the negative integral of 0 to x. We're just flipping our interval of sine of t dt. So when I take the derivative of this function in terms of x rather than in terms of t, it undoes the integral, but the negative still comes with us and becomes negative sine of x. That is our derivative of our function. For our third example, you're going to see that we have a little bit more going on in it. Not only is it a reversed function, but it also has another function inside, which means that we're going to have to use that idea of composite of functions. So for this example, the first thing I'm going to do is I'm going to rewrite this and negate and change our interval or flip our interval. Now, instead of just being in terms of x, what we have to do is find the derivative of 3x squared. So now you can see that composite of function ideas. So in this problem, I'm going to need to apply the chain rule. So when I apply the chain rule, I'm going to still negate because we switched our interval. I'm going to find that the derivative undoes the interval. It makes it the secant squared of 3x squared, but just like the chain rule, I leave the insides alone, and then at the end I multiply by the derivative of the insides, which gives me 6x, applying that chain rule. So with a quick simplification process, I find that my derivative of 3x squared gives me negative 6x secant squared of 3x squared. And that's how the Fundamental Theorem of Calculus Part 1 is used.